Doing question number 6 now for the same worksheet. Well, this is involving Fa1, which is a given concentration of sodium thiosulfate. Fa2 is the unknown, which is copper sulfate. And you are provided with Ki and starch as indicators. You are to find out the grams per dm cube of Fa2. And like all concentrated solutions, we dilute Fa2 first. In this case, I told you to take 47.00 as your dilute volume. That converts Fa2 into 250 of Fa3. Now, and then I'm assuming that you titrate Fa3 against Fa1. Absolutely. You take 25 cm cube of Fa3, which is the dilute copper sulfate, and you titrate that against Fa1, whose volume I believe I've given you is 24.75 cm cube. Right here. So let's get on with solving the question. Next page. 24.75. So yeah, in this part where it says record your titration results, you make the table and the answer is 24.75 as the average answer I'm going to get. And blah blah blah. Let's move down to the calculations bit. Now, they're asking me to find the moles of Na, sodium thiosulfate, which is in the burette. So when I know its concentration, all I gotta do is plug in this volume. And the concentration, I believe, I'll go back to the page. First page, let's go up. It's 0.15, I think. I'm on, yeah, 0.15 cm cube of sodium thiosulfate. So this is 0.15, and the volume comes from the titer, which, oh, we have it on the front. I have it on top as 24.75. So let's use that. 24.75 over 1000, and we get an answer. Let's find that out. So 0.15 into 24.75 divided by 1000. I get 0.003725 or 3.7125. So 3.7125 into 10 to the power minus 3. 3.7125 into 10 to the power minus 3. Now the next bit, how many moles of iodine react? Now the ratio for iodine to thiosulfate is 2:1. So the number of moles of iodine is to thiosulfate is 1:2. So whatever these are, 3.7125 divided by 10 to the power minus 3 is x, and we find x, which will be half of that. And let's find that out. Half of this, 1.8562. So 1.8562 into 10 to the power minus 3. Scroll up. Now they want us to find the moles of copper 2 plus, which are copper to iodine is iodine, not iodide. So iodine to copper is 1:2, and iodine of the previous part is 1.562 into the power minus 3 is to x, and when we multiply that by 2, we'll get the same values before. 3.7125 into 10 to the power of minus 3. On the next page, this is, by the way, in which part? Let me go back. This is in Fa3. Now, hence they want me to find the concentration of Fa3. So which is number of moles equal to Cv. Number of moles, I'll go back, was 3.7125. So 3.7125 into 10 to the power minus 3. And the volume is 25 cm cube because they came from a pipette. And the answer is divided by 25 into 1000. I get 0.07425. 0.07425. 7425. Okay. I found Fa3. Now they want me to find Fa2. Same solution. That means dilution. That means graduated flask. That means C1V1 equals to C2V2. C1 is your Fa2 and this is your Fa3. This is found in the graduated flask. Now, what's C1? We don't know. We know the volume of titer that was dilutes initially. The volume that was supposed to dilute, let me go back, it's 47.00 of Fa2. So in dilution I took 47.00 over 1000 is equal to C2, which is the new concentration of Fa3, which is 0.07425 into 250, because that came from the graduate flask, over 1000, and the thousands cancel out. It's 0.07425 into 250 over 47. So let me do the math for this. Into 250 divided by 47. I get 0.3949. I get 0.3949 moles per dm cube. And how do I find grams per dm cube? How do I do that? Well, moles per dm cube into mr is grams per dm cube. Moles per dm cube we got is 0.3949, and mr, if you do the math, it is 63.5 plus 1 plus blah blah. No, what am I doing? Plus 32.1 plus 4 times 16 plus 5 times 18 for water. So let's do that. 63.5 plus 32.1 plus 64 for oxygen plus 5 times 18 is 90. I get 249.6 is the MR. So 249.6, 0.3949 into that, into 0.3949. I get 98.6 through 3 sig figs. 98.6 grams per dm cube. Now the next part is about a few errors. I'll discuss this in class with you guys later, but that was a titration calculation.